Out of the three major HEBench components, a backend is a special program that contains the homomorphic encryption implementation of the workload that we want to benchmark. To benchmark the implementation, a user runs the front-end's application called test harness while indicating which backend to use. After the test harness application starts, it communicates and issues commands to the backend through the API bridge component of the abstraction layer. During execution, test harness measures the runtime of the workload implementation contained in the backend. Assume that we have a homomorphic encryption implementation of a workload and we want to benchmark it using the HEBench framework. To do this, we must create an HEBench backend containing a port of our implementation. A backend is a dynamic library. Dynamic libraries are shared object libraries, or SOs, in Linux, or dynamic link libraries, or DLLs, in Windows. Our dynamic library communicates with the front-end application, specifically with test harness, through the abstraction layer component. It must expose the functionality declared in the API bridge to be considered an HEBench backend. The API bridge specifies a common interface that all backends must define in order to be compatible with the HEBench framework. This interface is written in C, and it contains the functions and data types required to facilitate communication between a backend and the test harness application. This image shows the flow of data throughout the main functions involved in the benchmarking process pipeline. Each function is called by test harness in order, using the depicted output of a stage as the corresponding input of the next. Throughout the pipeline, test harness measures the time taken to complete each phase, but the main focus, in general, is on the operate function call. Depending on the benchmark category and configuration, this call may occur several times in an attempt to obtain statistically significant measurements. The rest of the pipeline is in place to support the operation. At the end of the benchmark, test harness validates results from the operation against known ground truth values. A benchmark is considered valid only once the results match with the ground truth. Once test harness completes the benchmark run with a successful validation, it produces a series of reports that detail the results of the measurements taken. Because the front end provides all the functionality regarding measuring, validation, statistical computations, and report generation, we only need to focus on the correct porting of our workload implementation into a backend. There are other functions in the API bridge beyond the core pipeline that allow for querying, initialization, and teardown of the API bridge objects. All these functions, including the core pipeline, must be implemented inside our backend. To ease developments of backends, the abstraction layer offers a C++ wrapper. This is a component written in C++ that offers a collection of predefined classes and functionality designed to hide boilerplate implementation and nuances required by the C API of the API bridge. The C++ wrapper assists with the backend engine initialization and termination, error handling, backend information query, and data flow and communication. For example, the communication between the API bridge functions and test harness occurs through opaque handles. Test harness receives these opaque handles as results from the different API bridge functions, and then uses them as input to other functions down the pipeline. An opaque handle is a C structure that requires careful manipulation to avoid memory leaks or dangling pointers. The C++ wrapper provides a handy set of methods to assist with automatic creation, duplication, termination, and extraction of information from opaque handles, thus freeing us from the complexities of the API bridge rules and allowing us to better focus on porting our implementation into the core pipeline. For information on creating a backend, refer to HEBench documentation and HEBench backend creation tutorials.